Hi everybody, hopefully you are doing well. We'll be starting our new chapter, which is chapter 12, lesson 1, heat. We'll talk about heat in this chapter, in this lesson. So, have you ever taken a sip of hot cocoa and you burn your tongue? Ouch. You might have, right? Energy in the hot drink flows into your tissues and damages them. Now, the energy that causes such a burn is heat. Heat is thermal energy that flows between objects due to a difference in temperature. Heat is measured in joules. Your tongue is cooler than the drink, so heat flows from the drink into your tongue. Now, heat moves from an object with a high temperature to an object with lower temperature. But what is temperature? Temperature is a measurement of the average kinetic energy of particles in an object. You know that all the particles in an object are vibrating with kinetic energy. Remember, anything which is moving has kinetic energy. So objects with a higher temperature have particles that are vibrating faster. Objects with lower temperature have particles that do not vibrate as much. So when a hot object touches a cold object, their particles bump into each other. Now, during these collisions, the particles from the hot object pass on some of their energy to the particles in the cold object. Now, the cold object becomes warmer and the hot object becomes cooler. Now, this process, when heat moves from one object to another, the temperature of each object changes. Heat will continue to flow until both objects are at the same temperature. For example, when you rub two things together, they can get warm. This is because friction between objects changes kinetic energy into thermal energy. Okay? Because particles in the object bump into one another, they move into one another as they are rubbed together. Each bump causes the particles to vibrate a little more and the temperature of the object rises. A temperature is measured with a thermometer. This is a modern thermometer. When a thermometer touches a material, heat will flow either into or out of the thermometer. Now, when the thermometer and the material are at the same temperature, heat will stop flowing because now they have the same temperature. This is what we just studied over here. That when particles in a hot object moves into a cooler object, they keep moving until the temperature is equal in both things. So when the thermometer and the materials are at the same temperature, the heat will stop flowing. The thermometer gives the temperature of the materials in units of degrees Celsius or degree Fahrenheit. Now, many thermometers work by measuring the way liquids expand or contract with temperature. That's why we use mercury or alcohol thermometers. Now, we often use the word thermal when discussing heat and temperature. Keeping in mind, though, that temperature and heat are not as the same thing. Temperature measures the average kinetic energy of particles, right? And heat is the total amount of thermal energy an object releases. So this is the difference. They are not same. Temperature measures the average kinetic energy of particles, while heat is the total amount of thermal energy in an object. So a small bowl of, for example, steaming soup has higher temperature than a cool lake, but the lake could release more heat because it has many more particles. So temperature and heat are two different things. Now, how heat actually moves? We have three ways of how actually heat moves. Let us say while stirring that hot cocoa, you might have noticed that your spoon got too hot to hold, right? That cocoa warmed the spoon and the spoon is just warming your fingers. Now, how did the heat get from that cocoa to your finger? Particles vibration have spread from the that cocoa to the spoon and then to your fingers. Conduction is the passing of heat through a material while the material itself stays in place. It occurs between objects that are touching. So conduction, when you are touching something and the heat moves from that object into you. Okay, this is conduction. On the other hand, convection is the heat spreading, or the convection is the flow of thermal energy through liquid or gas caused by hot parts rising and cool parts sinking. For example, you know that warmer air is less denser than the colder air. Okay, so as a hot air and cool parts of the liquid move, they cause rotating currents, right? The currents spread through energy through the material. Convection occurs in liquids and gases, but not in solids. Okay, we have, for example, solid things here are touching, so this is conduction here. Convection occurs mostly in liquids and gases. Okay, and now convection also causes many of the weather patterns on Earth because of changing in layer of gases. So this was convection, the transfer of energy by the circulation or movement of a liquid or gas. In hot air balloon, as you see, the hot gas from the fire rises the balloon, it becomes cooler, it comes down again, gets warmer again, then goes up, right? The cooler air will sink, warmer air rises up, cools, it sinks, again gets warm, and this is what keeps the flying balloon flying. Radiation. Now Earth's surface is warmed by radiation from the sun. Radiation is actually the transfer of energy through the electromagnetic waves. Now the rays include visible light, X-rays, and radio waves. So matter is not needed for this kind of transfer of energy. In radiation, there is no matter needed. You know, here liquid or gases are needed, here solid things touching up, but radiation does not need any help. Any matter is not needed. Electromagnetic rays can travel through empty space, otherwise heat from the sun could not warm the earth. You see, from the sun the heat comes directly to the earth without any help. So that is an example of radiation. Radiation is the transfer of heat through electromagnetic waves. So that was the lesson for today. Thank you. If you have any question, please feel free to ask at any time. See you in the next lesson. Thank you once again.